I've been thinking a lot about how to give Smarty WAN 2.0 a solid network. We're going to need a router, switch, antennas, access point, cellular, dashboards, and GPS.
So we can keep everything running when we're here, here, or here. Today, we talk networking. Today, we put on our IT hats and dig into smart home networking, specifically mobile smart home networking. If the compute core is the brain where Home Assistant integrates each device, then the network is the nervous system, the pathways all communication travels between devices and out to the internet. I'm going to show you the exact system we're installing in Smarty WAN 2.0, the recipe Shar and I use to keep our mobile smart home running and connected. That includes a PoE switch, a cellular router, antennas, an access point, and if you stick around to the end, a really slick way that we're bringing GPS data into Home Assistant. Plus, I'll show you a vSIM technology that I hadn't even heard of until recently, and I think it might just be the future of mobile connectivity. We've got a lot to cover, so first things first, every byte of data between every device in the vehicle flows through a router. You might be using a Wi-Fi router right now, either from your internet provider or one you added yourself. A mobile smart home is no different. We need a router to assign IP addresses, manage traffic, and connect everything to the internet. But in a vehicle, this thing becomes a lot more important because now we're not just connecting to the internet, you're managing cellular, Starlink, maybe even Wi-Fi-as-WAN, all while every smart device in your system depends on it working flawlessly. We've been using a Peplink Max Transit Duo Pro in our van for years. It's rock solid, but 5G is here, so for Smarty WAN 2.0, we're going with the Peplink Max BR1 Mini 5G. This is an enterprise-grade cellular router designed for mobile use. It runs directly on DC power, connects to external antennas, and acts like the central hub for both our local network and all of our internet connections. And that's where things get interesting. This router can pull internet from multiple sources like cellular, Starlink, or even Wi-Fi, and you can decide exactly how that traffic is used. For example, you might have your projector streaming over Starlink while your work laptop stays on a 5G cellular connection. You're in control of how everything routes. And if you want to take it even further, it can actually combine connections together using Speed Fusion Connect. So things like video calls don't drop, even if one connection hiccups. We've used this in our van, and it makes a big difference. And I actually use Home Assistant timers to manage this. I've got simple timers that temporarily route devices like my laptop through a bonded connection for things like video calls, then switch them back automatically. Now, one thing I highly recommend, create a separate Wi-Fi network just for your IoT devices. All of your ESP32s, IP cameras, smart controllers, etc. Put them on their own network so that they're isolated but can still talk to Home Assistant locally. It's a simple step that goes a long way for both stability and security. Another thing I love about Peplink is that it has a local API, which means we can build a Home Assistant dashboard to monitor and control the router. We even pull the client list from the Peplink router to determine presence. I've made a video about that you can find below. Now, Peplink routers are definitely not the cheapest option out there, but ours has been running in our van for years through heat, cold, and constant movement, and I think I've restarted it maybe twice. For something this critical, reliability matters. No matter which router you choose, you'll want to think about antennas. These little paddle antennas aren't going to give you a great signal inside a metal vehicle, so we move the antennas outside. We use a Parsec K9 7-in-1 antenna. It has 4 cellular, 2 Wi-Fi, and 1 GPS antennas all in this single package. You run the cables through the roof down to your router, and now you have a better signal for both cellular and Wi-Fi. It also allows the router to connect to external Wi-Fi networks, like a campground or coffee shop, and use that as an internet source for the entire vehicle. And as a bonus, you get strong Wi-Fi coverage outside your vehicle. But now your Wi-Fi is outside. So I'm going to show you how to get good Wi-Fi inside. But first, a huge thank you to all Smarty WAN members, especially our top tier Rhodes Scholars. We have a bunch of new members. Thank you so much for your support. I hope you're enjoying the members only videos. When we add an antenna to the roof of the vehicle, the router is now broadcasting Wi-Fi outside. The solution to this problem is to add an access point. We're using this Peplink AP1 Mini inside the vehicle. It pairs really well with Peplink routers and broadcasts Wi-Fi inside. You can even decide which of your networks are broadcast inside versus outside, and you can power the device using Power over Ethernet. The BR1 Mini only has a couple of LAN ports, and in a smart vehicle, that's not nearly enough. One of my core design principles is default to hardwired. This means network devices too. I'm not just talking about our phones or tablets or devices we move around a bunch. I'm talking about IP cameras, our compute core server, I/O and switching controllers, as well as our electrical system. And that's just a few of the smart components that live in our network. So to expand our network, we add a switch. For Smarty WAN 2.0, I'm using this 12-port PoE switch from Linevision. It runs on DC power and gives us 12 gigabit ports, including 8 PoE ports, so we can power devices like cameras directly over Ethernet. If you're not familiar with PoE, it sends power and data over a single cable, which simplifies wiring a lot. What I really like about this switch is that it supports local MQTT. That means I can create entities in Home Assistant and control individual ports, turning PoE devices on and off, and monitor power usage per port. This becomes really powerful when managing things like security cameras. You can automate them, power cycle them, or shut them all off at once, right from Home Assistant. I'll link to the Linevision switch, the MQTT protocol, as well as my config below. So now our network is feeling complete. All of our key components are hardwired to our Home Assistant server and to each other. We can even manage PoE IP cameras just by toggling ports from Home Assistant. I realize this setup can feel like a lot, and it's not the most affordable option, but I have something else to show you. If you don't want to manage an enterprise-grade router and switch, but like the idea of having most of these features and want multi-carrier cellular data with failover to WAN like Starlink, we found something pretty exciting. This is a TowerHop multi-carrier cellular router. We reached out to try their service, and they ended up sponsoring today's video. So thanks to TowerHop. Smarty WAN Studios has been running and testing this for the last several weeks, and I think you'll find this pretty interesting. This is their 5G cellular router with 4 LAN ports, 1 WAN port, and Wi-Fi 5 running firmware based on OpenWRT. This router uses vSIM, or virtual SIM technology, which enables true multi-carrier hopping between the big 3 US carriers, all for $88 per month. There's no throttling, deprioritization, or soft caps. You get full speed all the time with truly unlimited data. And unlike some multi-carrier eSIM options, your data is handled directly by the carrier you're connected to, not backhauled through a distant server. You buy the hardware and you own it. The service is prepaid monthly with no contracts you can pause or cancel anytime. TowerHop is constantly monitoring signal strength, and if your connection weakens, it automatically switches to another carrier with a better signal. And when you're out of cellular range, the router can fall back to a WAN connection, like Starlink. You don't really have to manage anything, but if you want to, their online portal lets you select a preferred carrier or run an auto scan that connects to each network, runs a speed test, and picks the fastest. There's also an API that I use to build this Home Assistant dashboard. This connects to their portal, so you will need an internet connection, but we're working with TowerHop to bring as many features as possible to local MQTT. I'll link to my config below. There are actually 2 modems in this router. One for vSIM management and a 5G modem for connectivity. That's why you see 8 antennas. If you're installing this in a vehicle with a rooftop antenna like we discussed earlier, you'll likely want an 11-in-1 antenna to support both modems plus Wi-Fi. I'll link to an example of that below. So in this one box, you get a Wi-Fi router, built-in switch, multi-carrier 5G data, and failover to WAN, all running on DC power. This might just be the future of smart vehicle connectivity. If you want to try out internet that hops with you, head to the link in the description and use code SMARTYVAN20 at checkout to save $20 off your first order. I'm using the 5G router, but they also have a hotspot option if you want something more portable. And if you do try it out, let us know in the comments or the Discord. We'd love to hear how it's working out for you. Thanks again to TowerHop for sponsoring this video. Alright, remember I mentioned our Peplink Max Transit Duo Pro had a GPS radio? Well, this BR1 Mini does not. So I came up with a pretty cool solution to bring GPS data into Home Assistant. The Seed Studio Compute core we're using has a mini PCIe slot we didn't talk about. It's designed for a cellular modem. So I installed a low-cost 4G modem that includes a GPS radio and simply disabled the cellular portion. I built a small Home Assistant add-on that sends AT commands to enable GPS and puts the modem to sleep. From there, I use GPSD to MQTT to bring that data into Home Assistant as a device tracker. This UFL to SMA connector creates a secure place to connect your GPS antenna from your 7-in-1 or 11-in-1 antenna on the roof. If your system doesn't have a PCIe slot, you could do the same thing with a USB GPS module. Now we always have GPS data, so Home Assistant knows where we are. And if you haven't seen my custom integration geolocator, it helps Home Assistant know when we are by turning GPS coordinates into location data and the correct time zone. This is critical for systems on the move. I'll link to that and everything I've discussed below. For Smarty WAN 2.0, we still need to talk switching, lighting, cameras, dashboards, and more. Until then, how about this one?